All right, so are you ready to dive into a topic that's a little unnerving but also really important?
Right.
We're talking software vulnerabilities, and you've sent us a ton of resources, articles, reports, even lecture transcripts. So it's pretty clear that you're ready to get serious about software security.
Yeah, I'd say that's a pretty accurate assessment. And, I've got my metaphorical tools ready to dig into these vulnerabilities.
Perfect. And to kick things off, I want to share a stat from the October 2024 report that really caught my eye. 26% of all attacks were malware. That's over a quarter.
Wow.
Ransomware was right behind it at 14%. And these things are impacting everyone, finance, education, even individuals like you and me.
Yeah, it's a constant battle out there. And sometimes it feels like the attackers are always one step ahead. But it's interesting. It's not always some master hacker behind these attacks.
Yeah, that's what I found surprising too. The YouTube lecture transcript we got really opened my eyes to how vulnerabilities can just slip in through the back door, so to speak.
Absolutely. A misconfigured system, a weak password, a missing encryption layer, any of those things can be an open invitation for trouble.
And of course, we can't forget about good old-fashioned human error. Like, remember that time I almost fell for that phishing email? It looked so real, supposedly from my bank. But if I hadn't double-checked the sender's address, well, let's just say it wouldn't have been pretty.
It happens to the best of us, but that's exactly why we need to shift from a reactive security mindset to a proactive one. Thinking about those threats and building defenses before they even become a problem.
So less putting out fires and more fireproofing the building in the first place.
Exactly. And, I found Gary McGraw's definitions in that transcript really helpful. He talked about the difference between application security, which is reactive, and software security, which is proactive.
So let me see if I understand this. Application security is like calling the plumber after the pipe bursts, while software security is making sure the pipes are strong and well-maintained from the start.
Perfect analogy. It's all about incorporating security into every stage of development, from the initial requirements all the way to deployment.
So instead of patching things up later, we're building security into the very foundation of the software. But how do we actually do that?
Well, one powerful technique is called threat modeling. Basically, you put yourself in the attacker's shoes.
Okay, so I'm a hacker now. This sounds kind of fun, but where do I even begin?
You start by asking, how could someone try to exploit my system? What are the weak points? What are the most valuable assets that someone might target?
So it's kind of like a detective game trying to anticipate the attacker's moves.
Exactly. And there are some cool tools that can help us with this detective work. The transcript mentioned the Microsoft Threat Modeling tool and the open source Threat Dragon. They can help us visualize potential attack vectors and trust boundaries within a system.
Trust boundaries. That sounds a bit like something out of a spy novel. What exactly are those?
Okay, so imagine your software system is like a castle with different levels of security. A trust boundary is like a wall between those levels, marking where trust changes. For example, the internet is a public space low trust. But once a user logs into your system, they cross a trust boundary into a more protected zone.
Okay, I'm starting to get the picture.
Yeah.
So by identifying these boundaries, we can figure out where we need the strongest defenses.
Precisely. Now, remember those abuse cases we talked about earlier? Those are really important for proactive security, too.
Oh, right. Those scenarios where we imagine how someone might misuse our system.
Yeah, it's like planning for the worst case scenario, but in a good way. By anticipating how someone might abuse the system, we can build in safeguards to make it much harder for them to actually do any damage.
This is making me think about software development in a whole new way. It's not just about building something that works. It's about building something that can withstand an attack.
You got it. And there's another principle we should talk about: secure design.
So this is about building security into the design of the software itself, not just adding it as an afterthought.
That's right. Think of it like designing a house. You wouldn't wait until after the house is built to add locks on the doors.
Right? Definitely not. That would be asking for trouble.
Exactly. It's the same with software. We need to think about security from the very beginning during the design phase. This means things like minimizing attack surfaces, building secure authentication mechanisms, and following the principle of least privilege.
Hold on. Principle of least privilege. You've lost me there.
It's actually pretty simple. It means giving users only the bare minimum access they need to do their job. No more, no less. That way, even if someone's account is compromised, the damage they can do is limited.
Ah, okay, that makes sense. So it's all about minimizing risk by limiting access. I like it.
Mm.
But what about the code itself? How do we make sure that the code we write is actually secure?
Well, that's where defensive coding comes in, and it's a whole other fascinating layer of this security onion we're peeling back. Let's take a break here and come back fresh to tackle that, shall we?
All right, I've got my coffee refilled, and I'm ready to dive back into this world of defensive coding. It sounds pretty intense, but also kind of cool. Like, we're coding ninjas, deflecting attacks with every line of code we write.
Maybe not ninjas, but the analogy isn't that far off. Defensive coding is all about writing code that's robust, resilient, and prepared for the unexpected. It's about thinking like an attacker and trying to anticipate all the ways they might try to exploit your code.
So we're not just writing code that works, we're writing code that can withstand a siege.
Exactly. And one of the most fundamental principles of defensive coding is input validation.
So making sure that the data that users are putting into our software is actually what we're expecting.
Precisely. It's like having a bouncer at the door of your application checking IDs and making sure no one is sneaking in with a fake tote. If we don't validate input properly, we leave ourselves vulnerable to things like injection attacks, where attackers can try to slip malicious code into our systems.
That sounds pretty scary. What kind of damage can those injection attacks do?
Oh, the damage can be huge. Attackers can steal sensitive data, modify information, or even take control of entire systems. It's like giving someone the keys to your digital kingdom.
It's a nightmare scenario.
Yeah.
So input validation is our first line of defense against these attacks?
Absolutely. And there are a ton of different techniques we can use for validation, like whitelisting, blacklisting, and sanitizing inputs. But it's not just about preventing attacks, it's also about handling errors gracefully.
Okay, error handling. That doesn't sound quite as exciting as fighting off hackers, but I guess it's important too.
Oh, it's crucial. When our software encounters an error, it needs to handle it in a secure way. We don't want to leak sensitive information or give attackers any clues about how our system works.
So even when things go wrong, we don't want to give attackers an advantage.
Exactly. And another key aspect of defensive coding is using strong cryptography to protect sensitive data.
Cryptography. Now we're talking,
Yeah.
that's the art of secret codes, right?
Precisely. Cryptography helps us protect data both in transit and at rest, using algorithms and keys to scramble information so that only authorized users can decipher it.
So even if an attacker gets their hands on our data, it's just a jumbled mess unless they have the key.
Exactly. It's like locking your valuables in a safe that only you have the combination to. But, defensive coding isn't a solo mission. It's a team effort. And that's where code reviews come in.
Code reviews. So having other developers look over our code for errors and potential vulnerabilities.
That's the idea. It's like having a fresh set of eyes on your work, looking for things you might have missed. A good code review can catch a lot of security issues before they make it into production.
That makes a lot of sense. It's like having an editor proofread your article before you publish it. You don't want any embarrassing typos or factual errors slipping through.
Exactly. And just like editors use style guides and grammar checkers, developers have tools that can help them write secure code. We've got static and dynamic code analysis tools that can scan our code for potential vulnerabilities.
So these tools are like automated security guards, patrolling our code and sounding the alarm if they spot anything suspicious.
That's a great way to put it. Static analysis tools scan our code without actually running it, looking for patterns that might indicate vulnerabilities.
Yeah.
Then we have dynamic analysis tools, which actually test the code in a running environment, simulating attacks to see how it behaves.
It's like having a red team and a blue team working together to find and fix those security holes.
Exactly. And these tools can save us so much time and effort catching vulnerabilities that we humans might miss.
This is honestly starting to feel a bit overwhelming. There's so much to consider when it comes to building secure software.
I know it can definitely feel that way, but remember, we don't have to do everything at once. We can start by focusing on the fundamentals like input validation and error handling, and then gradually incorporate more advanced techniques as we gain experience.
That's reassuring. It's a journey, not a sprint.
Right. Exactly. And speaking of journeys, remember all those acronyms and initiatives we started to unpack before? There's a whole community out there dedicated to improving software security, and they've created some super valuable resources that we can leverage. Let's start with a deeper dive into the CWE.
Okay, the common weakness in iteration. It's like a massive encyclopedia of all the things that can go wrong in software, right?
It's more than an encyclopedia. It's a living document that's constantly updated with new weaknesses as they're discovered. Think of it like a treasure trove of knowledge about software vulnerabilities, categorized and organized in a way that helps developers avoid common pitfalls.
So instead of reinventing the wheel and trying to figure out every potential security issue on our own, we can learn from the mistakes of others.
Exactly. The CWE is an awesome resource for understanding the different types of vulnerabilities that exist, how they work, and what we can do to prevent them. And to help us prioritize which weaknesses to focus on, we have the CWSS, the Common Weakness Scoring System.
Hold on a second. We've already talked about CVSS, the Common Vulnerability Scoring System. How is CWSS different? It feels like we're drowning in acronyms here.
I know there are a lot of acronyms to keep track of, but both of these scoring systems are important for understanding the severity of security weaknesses.
Okay, so let's break it down. CVSS is for scoring vulnerabilities that we already know about, right? It helps us figure out which ones need to be fixed first.
That's right. CVSS is like a triage system for known vulnerabilities. The higher the CVSS score, the more urgent the fix. But CWSS takes a different approach. It's about assessing the potential severity of a weakness even before it's been exploited.
So it's like a risk assessment tool for weaknesses that might turn into vulnerabilities down the line.
Exactly. CWSS helps us zero in on those weaknesses that are most likely to be exploited by attackers, so we can prioritize mitigation efforts even before those weaknesses become full-blown vulnerabilities.
Okay, I'm starting to see how these scoring systems fit together.
Right.
CWE gives us the big picture of potential weaknesses, and then CWSS and CVSS help us prioritize the ones that pose the biggest threat.
You got it. And all of these initiatives, the CWE, CWSS, CVSS, they're all community-driven. Anyone can contribute to making software more secure by participating in these communities, sharing knowledge, and reporting new weaknesses.
I love that. It's like a global network of security superheroes all working together to make the digital world a safer place.
Exactly. And we can't forget about another community-driven initiative, the OWASP Top 10.
Ah, yes, the OWASP Top 10. That was mentioned in one of the articles, right?
Good. OWASP stands for the Open Web Application Security Project, and their top 10 list is like a greatest hits collection of the most critical web application security risks. It's a carefully curated list of the most dangerous vulnerabilities that web developers really need to watch out for, and it's updated regularly to keep up with the evolving threat landscape.
So it's basically a must-read for anyone involved in web application development.
Absolutely. The OWASP Top 10 is a super valuable resource for understanding the current state of threats and figuring out where to focus our security efforts.
Okay, so we've got our encyclopedia of weaknesses, our scoring systems, and our top 10 list of web app threats. It feels like we're building a pretty solid security toolkit here.
We're definitely getting there, but there's one more crucial piece of the puzzle. We need to talk about the economics of software security.
Economics. I thought we were talking about code and vulnerabilities, not dollars and cents.
Well, in the real world, everything has a cost, and software security is no exception. But here's the thing. Investing in security upfront can actually save us a ton of money in the long run.
It's like the old saying, an ounce of prevention is worth a pound of cure, right?
Exactly. Think of it like this. Fixing a leaky faucet early on might just cost you a few bucks for a new washer. But if you let that drip go on, it could lead to water damage, mold, and some really expensive repairs.
Ouch. So ignoring security issues is like letting that leaky faucet drip, only instead of water damage. We're talking about data breaches and financial losses.
Precisely. And there's a classic example that illustrates this perfectly: Microsoft's development of Windows Vista. They went all in on a security-focused development process and were able to slash vulnerabilities by a whopping 45%, potentially saving themselves millions of dollars in post-release patching and support costs.
Okay, that's a really powerful example. So investing in secure software development isn't just about avoiding risk, it's also about being smart with our money.
Absolutely. And it's not even just about the direct costs of fixing vulnerabilities either. There are also indirect costs like damage to your reputation, lost customer trust, and legal headaches to worry about.
Yeah, it's a total domino effect. One security slip-up can take down a company's whole reputation.
Exactly. That's why it's so crucial to build security into the core of our software right from the get-go.
Okay, I'm sold. Secure software development is a win-win. It minimizes risk and boosts quality. But let's get practical for a second. Our listeners might be developers, project managers, or just people who are curious about software security. How can they actually start putting these principles into practice in their work?
That's a great question, and honestly, it's not always an easy one to answer. There's just so much information out there, it can be tough to know where to begin.
I totally agree. It can feel like you're trying to drink from a fire hose.
Exactly. But here's the thing. We don't have to become security gurus overnight. We can start with the fundamentals, like understanding different types of vulnerabilities, learning about secure design and coding techniques, and familiarizing ourselves with the awesome resources that are available.
Okay, so take a deep breath, don't freak out, and start with the basics. What are some good first steps for someone who's ready to level up their security game?
Well, one of the most important things is to really develop that security mindset.
What do you mean by that?
I mean, thinking about security as an integral part of the development process, not just something you tack on at the end. It means always being on the lookout for those potential risks and vulnerabilities and constantly asking, how could this be exploited? How can we make this more bulletproof?
So being proactive and thinking like an attacker, even if we don't have a security expert title?
You got it. And another key step is to educate ourselves about all the amazing resources that are out there. We've talked about the CWE, CWSS, CVSS, and the OWASP Top 10. These are all fantastic resources that can help us learn about common vulnerabilities and how to avoid them.
Right, and these are all community-driven, so we're not in this alone. There's a whole army of security-minded people out there willing to share their knowledge and help us learn.
Exactly. And don't underestimate the power of networking and collaborating. Go to security conferences, join online forums and discussion groups, connect with other developers and security pros. The more we share and learn from each other, the stronger we'll be as a community.
It's like building this collective shield against those cyber threats.
Precisely. And speaking of shields, there are also tools and technologies that can help us automate some of those security tasks, which can make our lives a lot easier.
Tell me more about those tools. Anything that can make security a little less intimidating sounds good to me.
Well, we have those static and dynamic code analysis tools that can help us spot potential vulnerabilities in our code.
Oh, right. We talked about those before. It's like having an automated code reviewer looking for any security loopholes we might have missed.
Exactly. And there are also vulnerability scanning tools which can pinpoint known vulnerabilities in our systems and applications.
So those tools can help us find those leaky faucets before they cause any major damage.
You got it. It's like having a team of digital plumbers on speed dial ready to patch up any leaks they find.
This is really starting to come together. We've got our community of security experts, our toolbox full of cool tech, and our own growing knowledge of how to write secure code. It feels like we're in a pretty good place to start tackling these software security challenges.
We're definitely on the right track. But remember, it's an ongoing process. The threat landscape is always changing, so we got to keep learning and adapting.
It's like that never-ending game of cat and mouse with the attackers coming up with new tricks and us trying to stay one step ahead.
Exactly. That's what keeps things exciting and challenging. It's a constant learning curve.
Well, I think we've covered a lot of ground today, from the basics of software vulnerabilities to the importance of having a security mindset and all the tools and resources that are available to us.
I agree. We've touched on some really important concepts and hopefully given our listeners a solid foundation for understanding this complex and ever-evolving world of software security.
I think this is a good place to pause for a moment. Give our listeners some time to process all this info before we wrap up with some final thoughts in part 3. All right, welcome back to our deep dive into the world of software security.
Yeah, it's been quite a journey exploring this whole landscape of vulnerabilities and figuring out how to make our systems more resilient.
You know, as we were talking about those tools and resources earlier, I had this realization.
What's that?
It's so easy to get lost in the technical details. But at the end of the day, security really boils down to people.
I couldn't agree more. Technology is just a means to an end. It's the people who design it, build it, use it, and maintain it that ultimately determine how secure it really is.
Exactly. We could have the most amazing, super advanced security systems in place, but they're only as strong as the weakest link in that human chain.
Remember that phishing email you almost fell for? That's a perfect example. Technology alone can't always save us from human mistakes or people with bad intentions.
So what can we do? How do we make sure that people are actually part of the solution and not the problem?
It all starts with education and awareness.
So making sure everyone gets why security matters and how they can help keep things safe.
Exactly. We need to create this culture of security where everyone feels comfortable reporting anything suspicious, asking questions, and speaking up if something seems off.
And that culture really needs to start from the top right. Leadership has to set the tone and make it clear that security is a top priority.
Absolutely. Security can't be an afterthought or something that just gets handed off to a small team. It needs to be woven into the fabric of the organization.
So it's not just about writing secure code, it's about building that security mindset across the entire organization.
Exactly. And that mindset needs to go beyond just the developers and the engineers. It needs to reach everyone who uses technology.
From the CEO down to the interns, everyone needs to understand the risks and take responsibility for their own actions.
It's like this, we all lock our doors at night to protect our homes, right? We need to have that same level of awareness when it comes to our digital lives.
I love that analogy. It's
Yeah.
about making security a habit, something we just do automatically without even thinking about it.
Exactly. And just like we teach kids about stranger danger and how to stay safe online, we need to educate ourselves and the people around us about the potential threats in the digital world.
So it's all about fostering this sense of shared responsibility where everyone realizes that security is a team effort.
And it's an ongoing effort. The bad guys are always coming up with new tricks, so we need to be constantly learning and adapting to stay ahead of the game.
Which brings us right back to those resources and communities we were discussing earlier. They're not just for the security pros, they're for anyone who wants to stay informed and stay ahead of the curve.
I really encourage our listeners to dive into those resources, connect with other folks who are passionate about security, and never stop learning.
So as we wrap up this deep dive, what's the one thing you really hope our listeners will take away from this?
Security is a journey, not a destination. It's about constant learning, adapting, and working together. And most importantly, it's about understanding that we all have a part to play in making the digital world a safer place for everyone.
That's a great way to put it. So that's all for our deep dive into software security. We hope this has been a thought-provoking and empowering exploration of this super complex and ever-changing world. Remember, knowledge is power, and by joining forces, we can create a more secure future for all of us.